Hi, we're going to talk today about the 7620 and typical setup. Normally we will have a 7.5 or 8.5 digit DMM. We've got a Fluke 5700 calibrator, and we're going to hook up a AC shunt to our 7620. First step would be to attach the AC shunt. Cables should remain as short as possible, and the hookup through to the Fluke 5700. We have the output on the left of the 5700 connected to the bottom two terminals, which are high and low, and the sense from the 5700 hooked up to the top inputs labeled current, negative, and positive. Pause. Hi. The AC shunt. When connecting the AC shunt, we need to have shortest cables as possible. To do this, we use a series of adapters. Once they're attached to your shunt, you attach it to the 20 amp range, because that's the first range we're going to show off using. We use this length to get past the handle of the unit, but it has the shortest cable possible and also supports the unit. The Fluke 5700 is in standby, so what we're going to do is send it to operate and then select the 20 amp scale in the 7620. So now we have an actual zero input going into the shunt, and the DMM will record the actual zero happening because it's sensing zero being put into the shunt. And we're going to add 1 volt to our Fluke calibrator, and we're going to read our DMM after it stabilizes. We're using a 0.01 ohm shunt, so we're reading 0.2 volts DC up here, and then we'll change the polarity to negative. And we'll wait for our DMM to stabilize, and we'll read minus 0.2 volts. And we'll add 1 kilohertz, actually, to our Fluke calibrator, and we'll switch our DMM to AC volts and wait for it to stabilize and read 0.2 volts. And we will go add 10 kilohertz to our Fluke calibrator through our shunt, and we will again read 0.2 volts on our DMM. And we're going to disconnect this shunt. First thing we're going to do is switch it out of the 20 amp range. The 20 amp range is more susceptible to overload with no shunt connected to it. The 2 amp range does not have that risk. So we'll take this shunt off. BNC connector and the UHF. Tighten that down. Tighten that in, and stop. Okay, so I hooked it up to the wrong range, so we just demonstrated the 2 amp range, 20 amp range. So now we're going to demonstrate the 2 amp and lower range and hook it up over here. Once that's in and tight, check that that's tight, and then we'll come over here and we will apply 1 volt on our shunt. Watch our DMM in DC volts, and it comes up to 2 volts. We'll change the polarity on our DMM, or on our Fluke, to negative, and we'll have negative 2 volts up here. apply 1 kilohertz and change our meter to AC volts, wait for it to stabilize and read 2 volts AC. We'll apply 10 kilohertz and watch our DMM stabilize again at 2 volts. Of note, once the voltage has been applied for any measurement, ensure the external sense is used with the Fluke 5700 for all measurements. Hi, we're going to now talk about the 7410 AC voltage reference. It has selection for waveforms and frequencies. We also have a DC reference, internal, which can be used when we use the shorting links to take the internal, short the in to the out. That uses the DC internal. We can also take the links out and the customer can supply their own DC reference. In the back of the unit, there's also an option to supply an external clock, 10 megahertz, which is also the same frequency as what's used internally. So for function, we have our oscilloscope hooked up to our AC output, and we also have a DMM hooked up, set to AC, to monitor the AC coming out. I will select a waveform. We'll say select waveform number 2 and frequency number 2. And we can see on our oscilloscope that it's showing 38.9 kilohertz. And that particular waveform. And our DMM over here is showing us 6.97 volts AC. So we can select a different waveform and a different frequency, and we'll take a look at that. And it is showing we have 611 hertz, and we have waveform selection A and frequency selection 8.